Welcome to the third tutorial in OpenCV. Thank you for watching. In this tutorial, I'm going to show you one thing real quick. In PyCharm, down at the bottom where it says Python packages, the tab, click on that inside your PyCharm. And it pops up a little search bar. You can find Python packages that are already installed. For example, you can type in OpenCV, and it has documentation to OpenCV. If you click on OpenCV on wheels over here, it has installation and usage. So if you can see right here in small print, it says installed, one found. So OpenCV is installed. That's important when you do the search. Now, we're going to go to Google OpenCV in your search bar. Don't use Bing, use Google. And then we're going to go to tutorials. Now we're going to go to core functionality, mass operations on matrices. Mass operations on matrices are quite simple. The idea is that we recalculate each pixel's value in an image according to a mask matrix, also known as a kernel. The mask holds values that will adjust how much influence neighboring pixels and the current pixels have on the new pixel value. From a mathematical point of view, we make a weighted average with our specified value. So think about what that means. It means we're averaging everything across our image. So our test case, let's consider the issue of an image contrast enhancement method. Basically, we want to apply for every pixel of an image the following formula. So here's a formula. And then, so it says the first notation is by using a formula, while the second is a compacted version of the first by using a map. So here is the mask. You can either use the formula or you can use the matrix. So the double arrow means interchangeable. And so this is the mask version. You use the mask by putting the center of the mask matrix in the upper case noted by the 0, 0 index on the pixel you want to calculate in some of the pixel values multiplied over with the overlap matrix values. It's the same thing. However, in the case of large matrices, the later notation is a lot easier to look over. So the mask is a lot easier than this long formula. M here stands for mask, and it's just a matrix. And you have INJ, row and column. That's what INJ is. So now here's the code. So we have C++, Java, and Python. We're doing everything in Python. So click on Python. So it says you can download the source code from here, which is a link, or look in the OpenCV source code library sample directory below. I've noticed that it's better to click on the link than it is to cut and paste the code from here. For some reason, when you click on the link, it has it keeps the indentation, proper indentation. So I click on here, and so now, I think you can hit Control A, and that'll select everything on the screen, and then hit Control C. And you can check that by scrolling down. And Control A is select all, and Control C is copy. So we hit Control C. Now we're going to PyCharm, and we're going to hit Control V. Now there's going to be an error, but I'll show you what that is. So let's hit Run. So if you can see, it says there's an error on line 56 in main. So we're going to click on that error, and it'll get us right to line 56. So the error is in the cv.imread, cv.samples.findFile file name. So we're going to change this cv.samples.findFile name with starry_9 And you can see it's auto-populating for us. So we double click on the auto-population and it'll fill in. If you remember from the second tutorial, we downloaded starry_not.jpg to our desktop, and we dragged it from our desktop into the Python project 7. So it's just a drag and drop from the desktop. And now we're gonna rerun, and depending on the speed of your computer, it may take a while. But basically, we're gonna have the original image, and then we're going to have the image enhancement method, which basically what it did was it averaged everything. So it's going to look more of a uniform instead of having, where you have real bright and real dark. Now you have more of an average. Here we go. We're going to show you the output. So here was the output. Now we're going to show you what the input was. And this was the input. So if you can see that the input is a lot brighter than the output was. So now we're going to go back. I'll show you so you can see both on the same screen. Now we're going to go back to our OpenCV tutorial. So we're back at our OpenCV tutorial, and we're going to hit the back button. Then we're going to click on Python. So that was our image contrast enhancement method. We did the first one. And if you can see right here, it says this was what it had. It had our input and our output. So let's go down. So the next method, the basic method. Now let's see how we can make this happen by using the basic pixel access method or using the filter 2D function. Here is the basic pixel access method. I wanted to let you know the function we ran was the handwritten function. And it took us about 18 milliseconds on the Starry Night image. So remember the handwritten function. That's what we used. This is the basic pixel access method. And you can run this in Python if you want in your integrated development environment, PyCharm. I'm not going to run the basic pixel access method, and then we'll see below the filter 2D function. If they say at first we make sure the input image data is an unsigned 8-bit format, we create an output image with the same size and same type as our input. As you can see in the storing section, depending on the number of channels, we may have one or more subcolumns. We need to access multiple rows and columns, which can be done by adding or subtracting one to the current center ij. Then we apply the sum and put the new value in the result matrix. That's the basic. You can read more about it if you want. Next, the filter 2D function. Applying such filters are so common in image processing that in OpenCV there is a function that will take care of applying the mask, also called a kernel in some places. For this, you need to define an object that holds the mask. Then call the filter 2D function, specifying the input, the output image in the kernel to use. The function even has a fifth optional argument, specify the center of a kernel, a sixth for adding an optional value to the filtered pixels before storing them in K, and a seventh one for determining what to do in the regions where the operation is undefined borders. This function is short or less verbose, and because there's some optimizations, it is usually faster than the hand-coded method. For example, in my test, while the second one took only 13 milliseconds, the first one took around 31, quite some. In PyCharm, we use the handwritten function. They say, for example, there's a couple images to compare. It's up to you, but I would use the faster. I would use the filter 2D function. But you can explore this more on your own. We're going to continue. We're going to hit the back button. And we're going to go to operations with images. And of course, we're going to be in Python. So you have C++, Java, and Python. Click on Python. Operations with images, input, output, images. Load an image from a file. As you can remember from our first tutorial, image equals cv.imread, and then you have your file name. In our case, the file name was Starry Night. If you read a JPEG file, a 3-channel image is created by default. If you need a grayscale image, use image equals cv.imread. And then your file name, cv.imread grayscale. In our case, of course, our file name was starry_night.jpg. And they say, no, format of the file is determined by its content. First few bytes. To save an image to a file, cv.imwrite file name image, starry_night. No, format of the file is determined by its extension. Use cv im decode and cv im encode to read and write an image from to memory rather than a file. Basic operations with images, accessing pixel intensity values. We'll pick up here next time with the 4th tutorial. Thank you for watching. And if you have questions or comments, please make them below the video. If you like the video, please give a thumbs up. Thank you for watching.